Nitrogen Production for Abbott Nutrition by Ian Farncrod, Seth Wentworth, and Catherine Reel. Today we're going to talk about our project to give Abbott Nutrition a reliable source of nitrogen. I'll give us a general overview and talk about PSA generation. Then Catherine will talk about cryogenic generation. And finally, Ian will fill us in on our current state of our project and what our next steps are. But what is nitrogen blanketing? In short, it's any system designed to prevent oxygen and other contaminants from contacting sensitive products. It's used for everything from preventing fires to simply keeping materials from degrading in the presence of oxygen. In this case, however, it's used to prevent oxygen from coming into contact with food products to prevent spoilage. Of course, in order to have a nitrogen blanketing system, you need access to a large supply of nitrogen. Over the next few slides, we'll talk about different methods to produce such large volumes. Shown here is a before and after of a pressure swing absorption system. On the left part, you could see two different tanks, which is common for commercial units. One tank is adsorbing, increasing pressure and absorbing oxygen to the surface, leaving only nitrogen in the output. The leftmost tank is desorbing oxygen and has a small throughput of nitrogen to purge out the excess oxygen. As one tank reaches maximum pressure and the other reaches minimum pressure, the valves are switched and the right part of the diagram is produced, in which the tank that was desorbing is now absorbing, and the tank that was adsorbing is now desorbing. A production PSA system switches between these two modes to produce a steady state production of nitrogen. Pressure swing absorption systems can achieve up to 99.999% purity, with an output pressure similar to that specified for the plant pressure. However, due to the purity requirements, multiple units will be required to achieve the required throughput. However, with the relatively low cost of 7 cents per thousand stuffs, if you count a compressor required to bring the input pressure to the required pressure for the PSA system, this makes it ideal for mid-size production for intermittent use.
A cryogenic method of production for nitrogen was also considered for this project. This method is quite different from the pressure swing absorption method that Seth detailed previously. First, the gas stream, in this case air, is filtered for any condensate that might be in the stream. It is then pressurized between 2 to 10 bar. This pressurization increases the temperature required to completely liquefy this airstream. This temperature still falls, however, within what is termed a cryogenic range, which is between -150 to -273 degrees Celsius, or what is better known as absolute zero on a Kelvin scale. After leaving the heat exchanger, the stream is sent into a flash tank where it is preliminarily separated, with any remaining gas being sent back through the process, and the liquid portion being sent into a train of distillation columns, with nitrogen being the top product and oxygen being the bottom product. The cryogenic method of nitrogen production can also achieve a very high purity of nitrogen, being 99.9 to the fourth decimal place pure, with Abbott Nutrition only requiring a 99.998% purity. The temperature range, as stated in the previous slide, is of a cryogenic level between -150 to -200 degrees C, which is not as low as absolute zero stated in the previous slide. This is due again to the low pressurization, which is between 2 to 10 bar, normally closer to 10 bar. And this pressure range does meet Abbott's requirement for their product pressure, being a 5.5 bar minimum. A company called Cosmodyne has prefabricated plants in their Linex line that meet the daily throughput required for the Abbott plant, this being 3,000 cubic feet per hour based on their high demand days. The Linex 25 model can produce double this throughput, whereas their Linex 5 model would require 2 units to achieve the 3,000 cubic feet per hour. And an example plant of one of their Line X models is seen in the picture below.
We realized that Abbott did not own their own storage tank to use for nitrogen storage, and so we began to look into options for storing the nitrogen. And we quickly realized that a lot of work would need to be put into compressing, cooling down the output from the PSA system, where the cryogenic system would produce something that could be put directly into a storage tank. And so we brainstormed a little bit, came to the conclusion that if we used the PSA system, it would be smarter to implement the system to cover daily throughput and to ask Abbott to continue to periodically purchase nitrogen tanks as they are currently doing to supplement any surges in need or any downtime on the system. Now, if they went with the cryogenic system, they would need to buy their own tank, and they could just use the cryogenic system to fill up the tank and then draw what they need off of the tank. So they would always have that sort of storage on site. And so we then went to them with these two different options. We then took all the considerations discussed in previous slides and compared the two systems on a gradient scale out of 10. The results are shown here based on safety, production costs, the ability to adjust flow rates based on swing and the production need, and then the conversion to storage conditions as discussed in the previous slide. And totals were tallied based on the need to either store nitrogen on site, or if Abbott was willing to continue to purchase nitrogen tanks periodically between those two eventualities. After discussing both systems with Abbott, we decided to move forward with the PSA system and got into contact with some equipment suppliers that have prefabricated PSA systems. Now we are still waiting on quotes from these suppliers, such as Air Technologies and Generon, so that we can run economics for Abbott to determine if this is a favorable project or not, based on the cost per cubic foot of nitrogen. But if the economics are favorable, we would pass all of the information that we have gathered, all of the research and work we have done to Abbott so that they can then implement this into their plant. And if it is not favorable, it was a good exercise for ourselves and Abbott to learn that they are actually paying a good price for nitrogen. And so that would be the biggest next step for this project. I would like to thank you all for your time. If you have any questions, that will be immediately after this.